Hello friends, welcome again to my YouTube channel, and today we're going to solve a new question from our top interview 150 question series. And today the question title is remove nth node from the end of the list. So this is the question, and this question belongs to linked list part, which we are currently doing. So let's understand the question. So we have been given the head of a linked list. So first point is we have been given the head of a linked list. Second is we have to remove the nth node from the end. So what we have to do is that we have to remove the given nth node from the given linked list, and we have to return the head of the resulting list. So here in example, you can see that we have been given the head of a linked list. That means this is the given linked list, and this is the value n, which is 2. That means we have to remove the node which is at the second position from the end of the linked list. So this is the requirement in this question, that we have to remove a node, and the position is given for that question, and we have to remove it from the end. Now let's understand the approaches by which we can solve this question. So this is the example which I have taken from the question, and this is the first example which we have discussed. So in this example, what we have to do is that we have to remove the node from the end of the linked list. What we have been given is that we have been given the position of that node from the end. So here we have been given that n equals to 2. So this is the given value. Now how you can remove this node? So what you do when you want to remove a node? So the simple thing which you do is that you arrive at a node which is previous to that node which you have to remove. So you will arrive a node just behind the node which you have to remove. So when you arrive at this position, what you can do is that you can simply write that your node next is equals to node next. So if you will do that, then what happens is that this node next will now point to the next position value, that is 5. By this, what you have done, you have removed this node from the entire linked list. Now this is the solution which you have to do. Now the question arises is how you will find this 3. We have been given n equals to 2. So what you can do is that there is two approaches which you can follow. So the first approach is, in order to find the index position from the start, the simple thing which you can do is that you can find the complete length of the linked list and subtract the given position. That means if you find the length, what is length? Length is 5, and it has been given the index need to be 2. So if you subtract that, what you will get? You will get 3. So this is the position from where you have to remove it. So if you do that, then you are able to find the index from where you have to remove the linked list, and you can simply remove it. So by using this, you what will happen, and if you see the time complexity in this situation, it will be 2n. Why it will be 2n? Because first you are iterating through the linked list for the part of your length. Second time you are iterating for the value which you will get by subtracting the value length minus given value, which is n. So it will give an time complexity of 2n. Now in order to reduce this, and there is a better and optimal approach which lies in this question, which we are going to discuss, and also we are going to solve in the same approach. So the approach is that what we can do is that we can take two pointers. So here we can take two pointers. Let's name it at a start, and second let's name it as you can say first. So it is not going to be a start. We are taking it as first and second. So these are the two pointer. First is first, then second. So what is the purpose of these two nodes? So in order to find the position from the start, what we are doing is that we are iterating throughout the linked list and finding the complete length. So in order to, and finally what we are doing, we are subtracting this. So while subtracting this, what we can do is that we can move our node such that it will subtract automatically. So let's think how we can do that. So what will happen if you move this first pointer two times, which is the given position from the end. So if you move this two times, it will first go to 2, then it's go to 3. So where your first will be lying, it is lying at the 3. So this is the position where first will be lying. Okay. Now next what we have to do is that we are going to move our start pointer along with the first pointer. These both are now going to move. And how you are going to move is that until your first pointer is not at the end of the linked list, we are going to move our both pointers. So you can simply see that what we are finally doing is that we are moving this start pointer how many times less? N times less. This is exactly what we are doing when we are subtracting these two values. That means in order to find this node, what we are doing, we are moving our node how many times less? L minus n times. So ultimately we are doing this. So here you can see that you have to, we will move the f to 4, then 5. How many times? 2 times. Again, when you start your s, how many times you will move? 2 times. So after that, what will happen? Your start will be at this position, which is your 3, and your first will be at 5. So this is the final what will happen, and this is your final. So, you have completely understand what I am trying to say is that previously we are using a brute force approach. That means what we are seeing in this question. Secondly, we have optimized its time complexity. And how we have done that? We have simply utilized the concept which we have generated. That means L minus n. What we are doing? We are doing L minus m. Firstly, we have moved n times. Then we are moving both simultaneously. By that, we will arrive at a position which will be equals to L minus n ultimately. So in how many iterations we have completed it? So it will going to move maximum n iterations. So now the time complexity will be n. So we have reduced our time complexity from 2n to n. So it is an optimal approach. So let's follow this approach and code now. So let's start. So what we have discussed is that we are going to take a two pointer. So first pointer is going to be our first pointer, which is also going to point to head initially, and we have another pointer which is second pointer, which is also be pointing to head. So now we have initialized two pointers. Now let's move on to the next step. So now what is the next step? So what we have to do is that we have to move our first pointer how many times? N times. So we will do that. So for int I equals to 0, I less than n, I plus plus. What we have to do? We have to write f equals to f next. So now, after this, there is one condition which we need to check that in order we are moving this part, what can happen is that there is a scenario where your f will be now pointing to which position? Null. When this will happen? When it is your n equals to 1. So let's assume your n equals to 1 and the length of the head is also equals to 1. So what will happen when you move one time f? It will be pointing to null. So what we have to do is that we have to check that if your f is null, that means if it is not equals to f. So if it is not null, then what we are going to do is that we are going to return. And what we can return? We can return head next. So this is the only one condition when it is going to be occur. So what we are doing is that we are simply returning head next. And what is head next? It is going to be null. Now what we have to do is that we have to run a while loop, and as discussed, until when we have to run this while loop? Until our first pointer will not reach at the end of the linked list. So we are checking until our f next is not null. So what we are doing is we are writing f next, sorry, f equals to f next. And next what we are doing, we are writing our second pointer which is s equals to s next. After completing this, our S will arrive at a position which is just previous to the node which we have to remove. So we can simply use the logic which is S next is equals to S next next. So this is the complete code. Now simply we can return head after removing the node. Now let's run this code. So this is accepted. Now let's submit this code. So this is accepted, and this is the question for today, and this is a simple question, and there is also a concept of two pointer in this by which we have reduced the time complexity. Now in the same video you will see the solution for both Java and Python. Now let's meet up in the next video. Till then, keep learning and exploring. Thank you all.